My name is Malcolm. I'm out of our North Andover office. I'll tell you a little bit about Revision first. We are a 100% employee-owned solar company. I also like to say we're a clean energy transition company because we install complementary technologies, heat pump water heaters, mini splits, backup batteries, EV chargers. But we are primarily a residential and commercial solar installer. So we do the whole process from design to installation to service. We've been in business for over 20 years, all across New England. Our office here in Massachusetts is North Andover. We've done dozens of projects on Cape Ann. So today we're going to talk about grid-tied solar. Basically, the one thing that wasn't covered with the other presentations. So real basic recap, you got panels on the roof, they're producing electricity. That electricity comes down off the roof through wires. It connects to your main electrical panel, and right there is where your electric meter is. And so the long and the short of it is, as electricity is being produced in real time, some of that may be consumed in the house. Electricity always wants to go the path of least resistance, or where it's demanded. So in times where you're producing more than you're using, it's going out to the street, it's getting used by your neighbors, but on its way out, it's spinning your meter backwards. And that's the concept of net metering, which we'll get into a little bit more. The main thing I want to impart on everyone, because we do free site assessments, right? So it's, a 5, 10, 15-minute conversation. We can get really deep with the specifics of your home. But I want to arm everybody, with maybe go to your neighbor's house or your parents or your friends or whatever. You could do this tomorrow morning with coffee. You could go outside the front of your house and you could basically do a quick rule of thumb. Is my house a good candidate for solar if you've never looked into it? So three main factors: orientation, which is relative to south, orientation compared to south being 180, roof pitch, and then shading or solar access. So those three are the most important to start. So if you walk out the roof that faces closest to south, you want to put your arms out 60 degrees of either side of due south, and you want the sun to be 60 degrees either side of which way your roof's facing. You want the sun to be somewhere in that range. Now you can go east, you can go west a little bit to some degree. Most roof pitches are going to be in the 20 to 35 to 45 degree pitch. 35 is ideal in our latitude, but it's actually okay to have a shallower pitch roof if you do have roof planes that are oriented east-west, because you're catching a little bit more of that sun as it crosses your ridge from east to west. And then main thing is you want an unobstructed view of the sun from the bulk of the day, 10 a.m. to 4 p.m., and the bulk of the year, February to November. So, what always happens in July, everybody says, "Oh, I've got a great roof for solar," because they look up and they see that one sunny spot somewhere. My parents do this to me every year too. Every year they think solar is better, and every year I tell them, you can't even grow tomato plants on your front porch. Like, you get this window from 11:30 to 1 p.m. and it only happens in the summer, and that's enough to grow a few measly tomatoes. But what you really want is to capture as much of the bulk of the year and the bulk of the day. Obviously, the sun's a little weaker in winter, a little weaker in the morning and the afternoon, but that does add up. So you want a big, clear, unobstructed view of the sun. And then roof shape is a huge piece. So the example I always use is the House of Seven Gables. You do not want your house to look like the House of Seven Gables. You want one gable, ideally. Ranch, cape if there's no dormers, big barn, colonial. Those are the types of houses that have good solar surfaces. You want big rectangles. Solar panels are bigger than you might imagine. They're as tall as I am. And if there were two of me side by side, it'd almost be as wide as the two of us, shoulder to shoulder. So they're big. And so you want an unobstructed roof plane free of vents and skylights, dormers, and so forth. And really that just has to do with keeping project costs down, right? To do a panel up in that corner and 2 panels over here and 3 panels over here, it starts to get a little clunky and expensive. You've seen them around, it's definitely possible, but the more you can minimize that, the better the project economics are. So here's an example. This is a project in Rockport. We did the heat pumps. You can see, this was a new construction, so the homeowners were able to, I think they even modified this roof at the last minute to give it a little more overhang to fit the panels nicely. We did a few more up on that upper ridge, and then the rest, they wanted the dormers and all the things that make architecture interesting. So able to kind of marry those two worlds. And then roof coverings. Asphalt shingle, thankfully, is the most common and the most simple. Metal standing seam is actually really good because we can attach the panels with all the same wind loading and all the engineering requirements without penetrating the roof. Rubber membrane's okay too, but it starts getting a little more labor intensive to make sure you seal those penetrations really well. No slate and no wood shingles, really just too tedious to make that work. Aluminum, who had aluminum shingles? Yeah, that can work too, but just more labor intensive to make sure you get it right and build the system to last. So recap, solar can be done on rooftops that look like this, but certainly a big rectangle is more ideal. Okay, moving on to net metering. This is one of the magical things that make solar work so well, especially in Massachusetts. This is how you can produce solar in Haverhill and have it move to your account in Gloucester, right? So net metering is this way that you push-pull with the grid, which means you don't have to change your habits. You don't have to wait till a sunny day to run the dryer. And you can create a big surplus in your summer months that fills in the gaps in your winter months. So as you're thinking about electrification, you're gonna be using heat pumps, which are gonna drive up your electric bill in the wintertime. You can cover that with your solar production and ideally even out over the course of the year. Credits, those net metering credits in normal case are coming back to the same account which they're produced, but they can be assigned anywhere. So this is where it works for landlords who can use one property as a place to produce the power and then send those credits as monetary value of the surplus solar to other accounts and start impacting other properties. Physical metering considerations. So simpler is better, right? We have to get power from the rooftop physically down to an electric panel, which is obviously fed by a meter. So let's picture an owner-occupied 2-family with 2 meters. Tenant pays one account and the owner pays the other. So that's a situation where you could do solar that covers first, it covers the owner meter. And if there's something left over, now you can work something out with your tenant. If you do want to send them surplus electricity credits, you can work that out yourselves. You could send that power to a third property if you wanted to. You can, a lot of different options there. A picture now let's say a 2 to 4 family. Each unit is metered separately, and then there's a common meter that serves just a few basic, exterior lights and a common basement. That's a really good situation as well, because even though that account doesn't use a ton of use a lot of electricity, just running the basics, the lights, you don't have a large electric bill. You're not looking to have massive savings, but you can dump a bunch of solar behind that meter, and then now you can partition it off. It's almost like a mini community solar farm, akin to what Brian was talking about, where that can now be partitioned to other accounts. So it's all just accounting. These credits don't expire, and they're essentially retail value. So a kilowatt hour currently is about 35 cents, all told, supply and delivery included, and a solar kilowatt hour is close. You got to subtract a couple small charges. And then third option, this gets, again, simpler is better. So this isn't the best, but it can be done. You could add a new service, right? You can drop a new meter and panel and wire in a few loads to a property and have that be the meter that then becomes the common meter that solar ties to. So added expense there to the project. That's the downside, but it does keep things cleaner if that's appealing. And then there's a number of incentives, which were already talked about. Just split these up into, they're very similar. The main one is a 30% federal tax credit. When it's a residential owner-occupied project, that's going to be your personal income taxes. If the property is a business, it's an LLC that owns the building. Now you're looking at rental income, and you have a different section of tax code, but it's still a 30% tax credit to help reduce that initial investment. There's a bonus in Gloucester, 10% if you're within that zone. There's an accelerated depreciation of the solar asset that can be actually very compelling. That can amount to a good chunk of reduction. And then renewable energy credits, which currently aren't anything to write home about, but potentially those could increase over time. They don't expire, and then the SMART program may incentivize, that's a production incentive like RECs are, that may drive some incentive over time.
What is accelerated depreciation?
Accelerated depreciation is a way to, I'm not a pro on it, but it's a way to take what that solar asset is, just like you would depreciate other assets. It's and you're able to take, I think it's 5 years worth in 1 year. So it's an accelerated depreciation. And then it's definitely worth mentioning, no solar project has to be out of pocket. Just like you go to buy a car, your two options aren't everything out of pocket or a lease. There's still path to ownership through financing. There's a number of credit unions here in the state of Massachusetts that have created solar-specific products. They're designed to incorporate the tax credit so that you're basically only borrowing the post-tax credit principal. Helps keep your monthly payments lower and makes it easier to swap a loan payment for an electric bill, and oftentimes become cash flow positive. So competitive rates for this type of thing: UMass 5 Credit Union, Eastrise, Clean Energy Credit Union. These are usually limited to primary residences, though. So for something like a investment property, you're going to have to look into business loans, of which I think Eastrise does. But you might be looking into other lines of credit that you might already have open for those properties, or construction loans, or and then of course the Energy Saver Home Loan Program would apply if you're doing more decarbonization work. So a couple of just quick case studies. A typical 8 kilowatt system on a good roof is producing 7,500 to 10,000 kilowatt hours a year. That might be about 90% of a typical home's consumption. You might have an installed cost of $31,000. You're subtracting the 30% tax credit. If it's owner occupied, primary residence, you can take the $1,000 Massachusetts state tax credit. So you've dramatically reduced your net investment, and then production incentives over time kind of trickle in. Most projects on, again, good solar roofs, you have a simple cash payback somewhere in the 6 to 10 year range, an IRR in the 10 to 15%. So I always like to compare that to what you can do in other investments. Solar being extremely safe because all you're doing is hedging against utility costs rising. And then not to mention, of course, the environmental benefits. I mean, just tons of carbon offset that would otherwise be sequestered by the trees. And then this is an actual physical example of a property in Gloucester, 2-family, collectively using about, spending about $6,700 on electricity each year. Now this is a bigger system on a nice, sunny, south-facing, almost barn-type roof, producing 15,000 kilowatt hours, so offsetting close to 80% of the annual usage. You can see the orange bar being the solar production. Everything below that bar is basically the electric bill being wiped out. Everything above that is residual electricity. So, 5-year payback, annual average ROI closer to 20%, and just tens and tens of thousands of dollars of long-term savings. Could finance this project and be cash flow positive from the start. And your average, if National Grid rates 35 cents a kilowatt hour, your kind of equivalent solar kilowatt hour is about 7 cents in this scenario. So there's a million more types of questions, and I think I'm already blown way past time. And yeah, thanks for your time.
Yeah.